Okay, example 6 is similar to example 5, except there's an extra force coming in, a 5g force that's coming in at an angle of 60 degrees to the slope, and it tells us the acceleration is moving 0.5 meters per second squared and asks us to find the mass. So the first thing we're going to do is we're going to complete our force diagram. So we do that by marking on the weight, which is mg. We find this angle in here, right, by imagining this right angle triangle. Right, we could draw it out if you want, we can put it in here, right angle triangle there, and then this will make this angle here 60 as well. Okay, we're going to use that later. Then we mark in the resultant, the reaction force, coming off the slope, and I'm just going to put the dotted line to show where that other end of that perpendicular reaction would be. It's going to help us when we come to think about resolving, is to always put that dotted line in so we can see which two directions when we're going into the slope as well. So the particle is, it doesn't ask us to find r, so actually in this question we're not going to find r. It asks us to find an expression for the mass. And to do that, we're going to resolve in the direction of motion. So we're going up the slope, so this is resolving up the slope, we're going up as positive, because it tells us we're accelerating up the slope at 0.5. So I always start off with the force. So if we think about the force, what's pushing it up the slope? Well, the only force pushing it up is this 5g force. It's not just pushing it up though, is it? It's also pushing it in. So because it's not parallel, we're going to have to do an adjustment, and to do that we think about whether to get to the line that's parallel with the slope we move through the angle or away from the angle. And hopefully we can see that to get to there, the line of the slope, so that we're parallel to the slope, we've gone through the angle of 60 degrees, and if we go through an angle, it's cos of that angle. So cos 60 degrees. On the other hand, the thing that's pulling it back is the weight, right? So while this is pushing it up the slope, that's difficult for it because there's a force from the weight pulling it back. And that force is mg. And again, we've got to resolve to get to the line, and again we go through the angle here to get to the slope. So it's mg cos 60. We can use our favourite equation, force equals mass times acceleration. So this is 5g cos 60 minus mg cos 60 equals m times 0.5. Right? And m is what we want to find. Now notice, in the expression for the answer, it leaves g in. So though we know that g is generally going to be 9.8, if it asks us to leave g in the question, we're going to have to work with g as an algebraic expression and rearrange it so that our final answer is in terms of g. So all I need to do is get rid of these cos 60s and rearrange. So the value of cos 60 is 1/2. So this tells me that it's 5g times 1/2 minus 1/2 mg equals, again, it's 1/2 m. Right, 0.5 same as a half. So straight away when I see that, I think, well, I'm going to times through by a half, right, because there's a half in every term. So that leaves me with 5g minus mg equals m. I want to make m the subject, so I'm going to get m by itself on one side. So I move over this, so it's m plus mg. Then we've got two m's, I only want one m so that I can get m equals, so I'm going to factorise the m out, 1 plus g, and I'm going to divide by that term, 5g over 1 plus g equals m, which is the answer we are looking for. Okay, so m equals 5g over 1 plus g, and its mass, so it's kilograms, and that's my final answer. Okay, so every time we're going to do the same with these slope questions. You've got two options. You can resolve up perpendicular to the slope, or you can resolve up the way, and it's always going to be using force equals ma along with those rules about whether it's cos or sine because you're moving through an angle or away from an angle.